Crime Science, Chapter 3. Predictive Policing. What if law enforcement could see crime before it happens? Not perfectly, not magically, but statistically, through the patient analysis of millions of data points. Welcome to Chapter 3 of Crime Science, Predictive Policing. In this chapter, we examine how big data analytics and machine learning are reshaping the fundamental orientation of police work, moving it from reaction to anticipation. Predictive policing represents a paradigm shift in crime science. It rests on two pillars: big data analytics and machine learning. Together, these tools allow law enforcement agencies to forecast crime trends, predict incidents, and dynamically allocate resources to areas of greatest need. Big data analytics begins by dismantling the walls between information sources. Traditional policing relied on incident reports, narrow, after-the-fact records of what already happened. Modern analytics integrates far more: emergency calls, weather patterns, socioeconomic indicators, urban infrastructure data, and even open-source social media. By combining these streams, agencies build a richer, more contextual picture of crime than was ever possible before. First analytical task is identifying patterns in space and time. Crime is rarely random. It clusters. Hotspots emerge in neighborhoods with poor street lighting, high population density, or concentrated socioeconomic stress. Big data analytics maps these hotspots with precision, allowing agencies to direct patrols where they are most needed. Time matters just as much as place. Burglaries spike on certain weekdays. Vehicle theft surge during the holidays. Violent crime correlates with temperature, with humidity, with the rhythms of urban life. By recognizing these temporal patterns, law enforcement can synchronize deployment with predicted surges, improving response times and apprehension rates. This is where machine learning enters, where statistical analysis can confirm what investigators already suspect. Machine learning algorithms uncover what no human analyst could ever see. They process vast data sets, millions of records, hundreds of variables, and reveal hidden correlations between crime incidents and contextual factors. These algorithms function as digital detectives. They map the interactions between variables, detect subtle patterns, and produce forecasts about when and where crimes are likely to occur. The result is not certainty, it is probability, sharper, faster, and more granular than any earlier method allowed. Critical capability of these systems is real-time analysis. Modern algorithms do not wait for a quarterly report. They ingest new criminal reports, emergency calls, and environmental data, continuously recalibrating their predictions as conditions shift. When a sudden surge of incidents emerges in a specific area, the system alerts law enforcement immediately, allowing patrols to respond, investigations to launch, and community outreach to begin, sometimes before the crime wave even crests. This shift transforms more than tactics. It transforms resource allocation. Law enforcement agencies operate with finite personnel and limited time. Spreading patrols thinly across an entire jurisdiction wastes both. Predictive models concentrate effort where the probability of crime is highest, at the right times, in the right places. The goal is not to predict every incident. The goal is to deploy scarce resources with maximum effect. But predictive policing is not only about algorithms, it is also about people. Big data analytics, used responsibly, can become a foundation for community engagement. When agencies share data-driven insights with community leaders, residents, and stakeholders, policing transforms from something done to a community into something done with it. Where the data reveal that property crime correlates with local unemployment, partnerships with job training programs become a crime prevention strategy in their own right. Trust grows, cooperation grows, and long-term safety improves. But predictive policing also raises serious ethical concerns. Concerns that cannot be ignored. The first is bias. Machine learning algorithms learn from historical crime data. If that data reflects past inequities in policing, the algorithm can encode and perpetuate those inequities, disproportionately targeting marginalized communities. The second is privacy. The wider the data net, the deeper the surveillance. The boundaries of acceptable collection, retention, and use must be drawn clearly and held firmly. The third is over-policing. When algorithms repeatedly identify the same neighborhoods as hotspots, the resulting concentration of police presence can deepen the very patterns that produced the data in the first place. a feedback loop that erodes trust. The path forward depends on transparency, oversight, and pluralistic engagement. Law enforcement, technologists, civil rights advocates, and community members must build these systems together, or risk building something none of them can defend. In our next chapter, we move from predicting crime to identifying its perpetrators as we explore the science of biometrics.